All right, hello everyone. My name is Bindi Belanger, and I'm an Executive Program Director at Ticketmaster. I've been with Live Nation and Ticketmaster for a little over 4 years, and in my current role, I'm partnered with the Technical Operations team and work on strategic planning and organizational optimization, which is basically a fancy way of saying that I help the leadership team figure out what we should work on and how we should organize ourselves to work on it. So I am not an engineer, so if you're expecting to see any code up here on this screen, you're welcome to step out into another talk at this time. Today, what I will be talking about, though, is Ticketmaster's journey to becoming a cloud-native company. I'll tell you a little bit about our company, some of the challenges that we've faced in the past, and then the steps that we've taken over the last couple of years to help us arrive at where we are today. So Ticketmaster was founded almost 41 years ago, back in 1976. And in 1996, the website, Ticketmaster.com, was launched. And most people, when they think about Ticketmaster, they think of it as just the website. But in fact, in 2010, after we joined forces with Live Nation, we have a large number of business services that we provide, from selling tickets to producing concerts to even providing artist management services. We've sold over 465 million tickets to events in over 37 countries. Last year, our gross transaction value, which is basically the gross value of the tickets that we sold, was over $25 billion. So it makes Ticketmaster.com a top 5 e-commerce website. But my favorite statistic is that somewhere in the world, every 20 minutes, there's a Live Nation event happening. So being part of the product and technology organization, we're basically powering unforgettable moments of joy. In order to deliver those amazing experiences, we've got a really large, complex technical stack. We jokingly and fondly refer to our tech stack as the tech museum because we've got software from every era, and most of them, or many of them, are not ready for containers and cloud. Because Ticketmaster has grown so much in the last 40 years, we've amassed 21 different ticketing systems to sell everything from concert tickets to season tickets to your favorite sporting events to go see your favorite band play at a small venue. Those ticketing systems include over 250 different products and services. To build and maintain those products and services, we've got an organization of over 1,400 people globally, and they build that software on our private cloud today, which is about 20,000 virtual machines across 7 global data centers. We've got a huge network footprint, and our technology stack continues to grow every year. On top of that technology stack, we have a massive challenge in that we invite the entire world to come and DDoS our website every time we put a major artist or event on sale. So if Beyonce or Adele or Bruno Mars is selling their tickets, millions of fans will come to Ticketmaster.com in hopes of getting one of a few thousand tickets. You can tell from the spike there that we go from 0 to 150 million transactions excuse me, in just a matter of minutes. So even though we are the world's largest live entertainment provider, we have a lot of competition. Because we do everything from selling tickets to producing concerts, we've got a huge surface area, which means that competitors can come after us in any one of those parts of our business. In order to keep pace with our competition, we have to be really agile and very fast. But the scale and complexity of our 40-year-old business with all of our legacy technology makes making rapid changes really hard. The analogy that we like to use is if you can imagine turning a giant ship, right? To move everybody in the same direction is not an easy thing to do. So to recap, we've got a lot of competitive pressure across a large market surface area. We have legacy tech, which many of those systems are not ready for containers or public cloud. We've got a lot of technical debt with high interest rates that we're constantly trying to pay down, huge scale and complexity, and the challenge that we face with our on-sale demands. And then we have Black Friday every time a major artist goes on sale. So those are the business challenges, and then historically we've also had challenges just within the technology organization. Within technical operations, over the last few years, because of our legacy tech stack, we've had to put a lot of time and effort focusing on maintaining the stability of that infrastructure. For a long while, we were spending a lot of our time on constant firefighting, which meant that we had very limited resources to work on projects, to add new value and new features for our development teams. We had a lot of silos just within technical operations and a very specialized talent pool because of those silos. Now, those challenges made it very difficult for our developers to work with tech ops. We had a somewhat confusing support structure. Every time they submitted a JIRA ticket to us, they had to wait a really long time in order for us to turn that around. Because of the complexity of our tech stack, they were highly dependent on operations. They didn't have a lot of autonomy themselves. And the systems themselves, because of the way they'd been built, were very complicated. To get a new app deployed or a new environment built out, if we didn't have capacity on our private cloud, these are the steps that a developer would have to go through. And it often took several months, especially if it required purchasing additional hardware to build out our on-prem private cloud. So you can imagine the frustration that our development teams felt anytime they had to deal with technical operations. And then within operations, we had some frustration because each of our different areas functioned as its own mini team, right? There was not folks in the private cloud team that could do data center work. The folks on the network team weren't involved in defining and deploying our platform solutions. Systems engineering and application support were two different organizations, even though there was some overlap there. And then on top of that, because it took so long to deploy infrastructure, we had to build for our highest peak load plus 20%. Which means if we were expecting to sell tickets to something like a Beyonce concert, we had to build out our infrastructure to be able to support that, even though that on sale, that load would hit us for just a few minutes the morning of the on sale. So we had to build that out and have that always on. Because of that, it was really challenging to own and operate it. And the example I have here is we had to upgrade our version of MySQL for PCI compliance and other reasons. And it took us almost 2 years to complete that because we had hundreds of production databases that needed to be upgraded, which meant hundreds of development teams and developers that required coordination and timing and validation. By the time we finished that upgrade project, it was time to do the next version of the upgrades. And I'm sure if you're part of a large enterprise and have this level of complexity, you understand the pain that that causes. So basically our platform, which are software, systems, and teams, were not designed for dynamic scaling. So a couple years ago, Ticketmaster made a decision or a realization that we needed to become much more lean and create autonomous teams. The first thing that we did was really a concerted effort around a lean transformation, which meant managing our technology org like an investment portfolio. So from the top down at our senior executive level, they defined the vision, which for us is to connect with 1 billion fans by 2020, and then identified the goals that we needed to achieve in order to reach that vision. Within those goals, we would define bets, or we bet that if we did A, that would result in achieving our goal. And then those bets were broken down into smaller pieces of work called promises of value. So every delivery team was aligned around a POV, or promise of value. We would regularly review our progress against these bets and goals in portfolio reviews, and as a leadership group would make decisions around whether we needed to adjust, pivot, work on something else, or double down, meaning put more resources on the projects that were resulting in high value. So at the same time that was happening, our development organization grew by about 250%, so leaps and bounds. New developers were getting hired every week, but our operations team did not grow to keep pace with that. So we created 65 plus, I think it's close to 100 now because we've grown so much, cross-functional delivery teams, which included UX and UI, software developers, and QA. But you notice what's missing up there is operations. Because ops didn't scale to match the growth of the development organization, eventually all roads led to being blocked by operations. So while we had more developers, we got faster at developing, but we didn't get faster at delivering value because of that roadblock. So because of the roadblock, we realized we really needed to make sure that these delivery teams were autonomous, that they could do a lot of the work they needed to do on their own. One of the first steps that we did was we moved our application support teams out of TechOps and into the product teams directly. By removing that organizational silo, right, taking them out of ops and putting them directly with the people that needed to make those changes, we were hoping to remove a lot of those barriers. The next thing that we did was we embedded systems engineers into those product delivery teams, again, working to get towards truly cross-functional groups. But because we didn't have enough systems engineers, instead of having a 1-to-1 ratio, one systems engineer to one team, what ended up happening was we would have one systems engineer that was assigned to support 5 or 6 related teams. It wasn't ideal, but it was much closer to being truly cross-functional. That ended up resulting in fewer JIRA tickets because you remove that formality of having to submit a ticket that would sit in a queue for a while. Instead, your systems engineer was probably sitting right next to you and your team so that you could work much closer with them. We also made an investment in self-service tools, things like access management to servers, password resets, things that our ops teams were spending a lot of time doing. We found ways to automate and then make self-service. That also reduced the number of JIRA tickets coming into our queues. The goal of all of this was to create these delivery teams that were self-sufficient, like micro businesses. Their jobs would then be to build software, run it, own it, operate it, optimize it, and monetize it. We gained a lot of insights from doing this. As we got closer and closer to a truly DevOps culture, we found that almost half of our time we spent moving code around our different environments. It's not a really good way to add value, right? We also found that we had 150 different ways to release software. A lot of the times that was a manual effort. And we found that over half of our incidents were preventable because of the way that we had set up our deployments and releases. And so when we would have business disruptions or incidents, many of them were self-inflicted, unfortunately. So with those insights, we realized we needed more information, we needed more data, and so to give us better insight into how we could make more effective change. So we built maturity models. The 2 maturity models that I'll talk about today are our tech maturity and our team maturity. We wanted to be able to define and measure team performance and technical performance objectively. The tech maturity model has about 50 different capabilities, and I'll show you what it looks like in just a minute, that cover 5 different dimensions of software development. How we code, how we build and test that software, how we release it, operate it, and then optimize it. Every team went through a process of self-assessment guided by our architecture leaders and came up with an objective score and a clear path for improvement. TechMaturity.com was open sourced a few months ago, so if you want to know more about this, you can see me after the talk. So this is a snapshot of our score across all of the different product teams when we first did this about a year or so ago. You'll notice that we're really good at developing code and then coming back later and optimizing it, but we're not great at building and testing it and then operating it. Because of all the work we did around our lean transformation and moving towards more autonomous teams, you can see that our highest score was actually in the DevOps practice. So each of those capabilities had a description of what level 1, 2, 3, and 4 look like. And so wherever a team self-assessed, they would know what they needed to do to get to the next level. So you can see for DevOps, level 1 was environments in production are controlled by someone not on the team building the product. Right, so it was operations that owned the production environment, not the development team. Level 4 is that they were truly DevOps, that the teams who were building the products fully owned and operated their production environments, and was also responsible for handling any alerts or issue escalations that came from it. So this is a snapshot of the tech maturity model, specifically in the area of coding. You'll notice on the right-hand side, there's a minimum cloud readiness score. So what we were working towards is as we started moving teams to the public cloud, we wanted to define what the minimum level was in order for those products and services to function well in the public cloud. So in the test suite example, you'll see that the minimum cloud readiness is a level 3, which is that they actively maintain those tests and they're mostly successfully passing for positive flows. In this particular case, the team self-assessed at a level 1, and before they began their journey to the cloud, we wanted to ensure that they got to a level 3. So this gave them some guidelines. The feedback was really great when we started rolling this out to teams. Not only did it give them a really objective way to say, hey, we have some opportunities for improvement in our tech stack, but it helped facilitate the conversation with product leadership and senior leadership to say, if we can improve in these areas, we can start to move faster, we'll experience fewer incidents in production, and it enabled a conversation that we just weren't able to have before. Instead of talking to your product manager and saying, hey, we need to get faster, we need to pay down some technical debt, this really enabled a much more specific and actionable conversation. Next, we built a team maturity model that was really around the adoption and implementation of agile practices. We wanted to help teams figure out how can you move faster. So even if your technology is top rate, right, you're building modern software, using modern tools, if your team wasn't functioning as a high-functioning team, how did you get there? What did that look like? What steps should you take to improve? So we have a snapshot here of, this isn't the whole thing, but just a portion of it, of the team maturity model that included things like strategic roadmap. Does your team understand how the work that they're doing is contributing to the overall goal and mission of the company? Are your roles and responsibilities clear just within your team, or does everyone in the technology org understand who's responsible for what? Are you doing paired programming? Are you actively eliminating waste? So you would self-assess, like in that particular category, anywhere from a level 1, which is, hey, we have a Kanban board, to level 4, where the team is proactively eliminating waste based on cycle time and continually streamlining their processes. So the value here wasn't about saying, oh, my team is a level 1 or a level 2, but it was understanding where you were and what skills you needed to obtain to get to that next level. So we categorized teams into less mature teams that were still, maybe newly forming and still understanding the basics of things like agile best practices and Kanban, to teams that were working to get better, to our high performance teams that were always getting faster and serving as models for other groups. So we saw a huge value in quantifying our maturity because the scoreboards didn't lie. And we found, you might expect that by giving people scores, it would get competitive or people would get defensive, but it really helped facilitate really valuable and helpful conversations. We're currently building and tuning other models like the risk assessment model, cost optimization model, and then jokingly a model to optimize all the other models. So we were continuing our lean transformation, and then our senior leaders made the strategic decision that we wanted to move our products and services out of our on-prem data centers and into the public cloud. The two main reasons for that were, one, we don't need to spend a lot of time and money building out our infrastructure to be always on. We wanted to be able to have infrastructure that was more on-demand and scalable. But most importantly, the decision to move to the public cloud was to force modernization of our products and services to cloud-native standards. The benefits of moving to the public cloud are many, and they're not all listed here, and I won't go through every single one of them, but specifically on resource utilization, not just infrastructure resources like compute and storage, but how are we using our human resources, right? If your teams are spending all of their time building and maintaining and upgrading their infrastructure, they're not really spending time adding value, helping your development teams move faster. So we wanted to focus a lot of our time there. And then things like removing single points of failure, rich telemetry, shared nothing architecture were all really important reasons for us to move to the public cloud. So for Ticketmaster specifically, our decision to move to the public cloud was a decision to become a cloud-native company. So the next step for us was to change the way that our leadership team operated. More specifically around what operations leaders valued. So if you are a part of an ops team or you've spent any time in ops, you know that the two most important things are stability and uptime, which meant that you wanted to try and introduce as little change as possible, because when you make changes, that's when stuff breaks. We wanted to shift our leaders from focusing on not changing things to going more towards taking calculated risks so that we could enable speed and continuous delivery, which is basically another way of saying constant change. So how did we do that? First step, becoming a metrics-driven organization. In addition to our tech maturity and team maturity models, we began publishing telemetry on everything from uptime to failed maintenances. We created product scorecards, again, not as a way to create any sort of defensiveness or finger pointing, but to have more meaningful conversations. And then we reviewed them regularly in our leadership meetings to talk about how we could make improvements to those metrics. By having those metrics and having those conversations, we were working towards creating a culture where change was normal and not something to fear. We obsessed over mean time to detect and mean time to resolve, because if you failed, but you were able to detect that failure very quickly and recover quickly, that was okay, right? When we had major outages, we began doing blameless postmortems. We had a really massive one about a year and a half ago, and the postmortem involved almost 200 people, everyone from operations to software developers to our client and fan-facing teams. And instead of spending a lot of time finger pointing as to what caused the problem, we spent a couple days working through how can we make sure that this doesn't happen again in the future? What steps do we need to take? How do we prioritize that work? And then how do we work together in the event that this should happen again to recover even faster next time? And we constantly emphasized iterative delivery, iterative improvement, and made it okay to just try experiments and say, we tried this, it didn't work, let's try something else. The other main thing, specifically from a program management perspective, was we wanted to shift away from output and focus on outcomes. We were heavily focused on tracking and reporting and publishing story points, which that's one of the key metrics in an agile organization. And instead of focusing on story points, which don't really convey any sort of business value, we wanted to focus on business metrics and KPIs. Was the work that your software teams were doing, are you increasing conversion? Are you selling more tickets? Are you getting more visitors to the website? And by shifting the focus to how fast are we getting work done to are we doing the right work was really huge, especially from a leadership perspective. So we spent a lot of time on the leadership level, and the next area of focus for us was our teams. The technical operations team specifically has shrunk quite a bit over the last couple of years. One of the main reasons was because of the DevOps alignment that we were doing, right? We were moving application support teams and engineers closer to the product teams that they supported. We were also very strategic about where we backfilled. Because of a lot of the self-service and automation work that we had done had reduced the number of true ops or maintenance work that we were doing, we wanted to make sure we weren't just backfilling to backfill, but that we were getting the right talent and the right people to help us in our next phase. We also had to make some really difficult decisions about which projects that we needed to continue, and others that we said, you know what, we might be able to skip this upgrade and focus our efforts somewhere else that's going to add more value. Then our leadership team can I take questions at the end? Sorry. Then our leadership team spent some time talking through, as we're backfilling, as we're recruiting new team members, what kind of skill sets do we want? What are the characteristics of an ideal technical operations team member in this next phase of our journey? So we mapped that out, and I won't read through all of them, but if you want to take a quick picture. We broke it down into tech skills, soft skills, and then that sweet spot in between. Things like creative problem solving, having a knowledge of AWS and cloud primitives, excellent troubleshooting skills, right? Nowhere on here do you see any specific coding language or knowledge of a specific technology. In order to create the ideal cloud-native teams, we realized that smaller was better. 2 to 5 people teams have proven to be really successful for us. And when you think about 2 people as a team, it may seem a little strange, but we found that paired programming and having less people focus on the same problem allowed us to move faster. So again, we wanted people that had development backgrounds, which is something that's not easy to find if you're looking for people that also are really familiar with infrastructure. We have been looking for people that have either knowledge or have been contributing to cloud-native projects. And then from the soft skills perspective, again, creative problem solvers with a bias for action. We didn't want people that were like, we've done this for the past 5 years, let's just keep doing it, the status quo is totally fine. We wanted people who were constantly looking to drive and embrace change, committing code daily. So we did an assessment of our existing team members, and we found that what we really needed were people that were high performers today, right? People that are committing code, that are working on solving problems, and had an appetite for learning more and had potential to contribute even further in the future. Our leadership team was then tasked with continuing to do those types of assessments, working to upskill our teams as far as training them on cloud-native solutions, and then we have been actively recruiting to help augment our existing staff with people that can bring in outside expertise. So we've got our leadership, we've got our teams. The next step for us was organizing the work. And if you're from the ops background, you know that traditionally infrastructure projects have almost always followed a waterfall methodology, especially when it came to physical hardware, right? It's difficult to iterate there. You have to plan out what you're gonna do, the sequence of steps that you need to take to build and configure hardware. It's not something that was really easy to take an agile approach to. We could do that where the physical infrastructure already existed, so we might have some version of what I like to call scrummerfall, where you plan out some portion of that beginning step and then you iterate in terms of delivering those environments after the fact. But cloud-native projects are different. Because a lot of this is so new and it's constantly changing and we're constantly learning about new solutions, Waterfall, Scrum, and Kanban don't work without some level of adjustment. So for our case at Ticketmaster, as we kicked off our Kubernetes project, we took the time to do some planning. We iteratively delivered in building out production-ready Kubernetes clusters. Then we decided to partner with CoreOS. And so adding Tectonic into the mix caused us to take a step back, do some additional planning, iterate through that. As we were implementing Tectonic, we realized, hey, we need to add Prometheus, we want to use that for monitoring, and then Helm for package management. So this level of flexibility was really necessary to help us manage these projects. You can't stick to a single framework and say, this is the box that we're going to live in and we must live in that box. Because of that need for flexible frameworks, one of the things that we've done that has been really successful for us is we have 2-day on-site collaborative planning sessions. It may seem like a really obvious thing, right? If you're gonna have a project, you should plan for it. But for us, the keys here were doing them on site because our operations teams, our cloud native teams are largely remote. Because we're looking for the best talent within our company and then outside, we hire folks all over the world. But bringing them on site to work together, to build those relationships, and then to really visualize the work has been really important for us. In that session, we'll do things like defining our scope. What are the trade-off guidelines? Is it more important for us to deliver fast or for us to make sure we have every feature perfect when we deliver it? We would do architecture design sessions, get really clear on roles and responsibilities, and then rules of engagement have been really important for us as well. Again, because of the remote teams, a lot of our work is done via Zoom and Slack, so making sure everybody knew how we wanted to communicate was important. So coming out of these inceptions, the idea was that the team should be able to start working immediately the next day. But because of the flexibility that we needed to maintain with these cloud native projects, sometimes we would have more than one inception. We would do an inception, iteratively deliver, and then say, hey, we want to take a different approach, and we'd bring everybody back together. So with having flexible frameworks, you can't just have a traditional project manager. What we needed instead were leaders who happened to be programmer project managers. People that weren't able to creatively modify the established frameworks just really struggled to succeed. Especially if you have someone who's very used to setting a plan and then having the team follow it, this could be a very frustrating type of project to undertake. So the key characteristics for success in this role were that project managers who, like myself, may not be technical, they needed to understand enough of the technology that they could ask the right questions to drive meaningful discussions and decisions with the team. They had to have enough experience working on other projects to be able to ask the right questions. Why are we doing it this way? Have we talked to the teams about what they need? Have we documented our architecture and validated it with anyone? Have we leveraged our partnerships, right? So those types of questions and having the experience to ask them were important. And then constantly questioning the status quo. Just because we did it that way last time doesn't mean we should continue to do that the same way. And the other important piece of this is that our project leaders needed to be partnered with engineering leads and not in supportive or auxiliary roles, which oftentimes happens when you have someone like a scrum master, right? They're in service of the team, they're there to support, but they're not often seen as a leader. So for us, it was really important, specifically on cloud native projects that required flexibility, to have a leader in this type of role. Finally, we spent a lot of time fostering partnerships within the community. We spent time with CoreOS, with Kelsey. We flew folks out to spend time with us at our office and help us before we kicked off our inceptions. We've been attending as many cloud native and Kubernetes conferences as we can, hosting meetups really more to just understand what other teams are doing, what other people are using as far as solutions. We've joined several SIGs, and then most recently, a few months ago, we joined the Cloud Native Computing Foundation. So, leadership, highly skilled and motivated teams, project framework and leadership on the project front, and then community and partnership engagement has led us to a culture of daily delivery. So for us, daily delivery means, for one, we have twice daily stand-ups. Instead of having a weekly iteration or a month-long iteration, every morning the team will get together and say, what are we delivering today? And at the end of the day, you're asked to demo the value that you've delivered. So we get away from this 2-week iteration, or at the end of the quarter, we'll have something delivered. We'd like to see what we're going to get done each day. Because of cloud native solutions, we've gone from several months to deploy new infrastructure and environments to when we were in the middle of our DevOps transformation, we got down to a few weeks, and now with cloud native, it's just a matter of minutes. Same thing for feature releases. Because there was so much coordination required between our ops teams, application support teams, and software teams, releases didn't happen very often, maybe once every few months. With DevOps, we finally got to a more weekly delivery culture, and then with cloud native, teams are able to release new features as often as they need to during the day. One of the great use cases or case studies that we've seen is our new Ticketmaster web platform, which was built on Kubernetes and is still in its beta phase right now. Before Kubernetes, even though they were a modern team with great lean practices, they were building on new technology, it still took about 20 minutes or so to deploy with low confidence, right? They would often run into issues. With Kubernetes and Tectonic, they've got fully automated updates that can happen within a minute. And because of that, that helped to enable our daily delivery culture and high confidence with the teams. So, to recap, cloud native transformations within your company require major cultural transformations, from everything to how you define and set goals, how your leadership views the importance of outcomes over outputs, and then the skill sets and teams and the way that you organize the work. And I would argue that the way that you organize your delivery of cloud native solutions is just as important as the technology choices that you make. So methodology is just as important as the technology. So I'm here this week with my team from the US and the UK. Many of them are here, so if you have any questions specifically around the technology choices that we've made, these are the guys that you want to talk to, not me. And then we are actively hiring for both our US and UK teams. And that is it. Thank you very much.